Okay, let's see if we can find a general formula for the derivative of any kind of inverse function. With an inverse, we know that f of f inverse of x equals x. That's by the definition of inverses. So let's take the derivative of both sides. So that is the derivative with respect to x of f of f inverse of x equals derivative of x with respect to x. By the chain rule, we have that this is f prime of f inverse of x times the derivative of f inverse of x with respect to x, and that equals 1. So now if we divide this term on both sides, we get derivative of f inverse of x with respect to x equals 1 over f prime of f inverse of x. And this is for any inverse. So let's make a little box around that because we're going to use that. So this means that we need to know f prime, and f inverse in order to do an inverse. So let's take a simple example. Let's try f of x equals x squared. Well, if that's the case, f inverse of x equals x to the 1/2, or square root of x. Now, what do we know? We know that f of x equals x squared. Therefore, f prime of x equals 2x. We know that f inverse of x equals x to the 1/2. And we know that f prime of x to the 1/2, which is x inverse, equals 2 times x to the 1/2. Well, the derivative of f of x, of x to the 1/2, which is the inverse, x to the 1/2 with respect to x equals 1 over 2x to the 1/2, which corresponds to other ways we have of finding the derivative of square root of x. Let's try another example, also familiar to us. So f of x equals e to the x. F prime of x also equals e to the x. F inverse of x is the natural log of x, or ln x. And f prime of ln x equals e to the ln x, but that simplifies to x. So the derivative of ln x with respect to x equals 1 over x, which also corresponds to what we know. But let's try ones that are generally a little less familiar. So here we have f of x is sine x. F prime of x equals cosine of x. F inverse of x is arcsine of x. And f prime of arcsine of x equals cosine of arcsine of x. In order to make a simpler expression of that, let's figure out what it means. Well, if we look at the inside first, let's draw a triangle. And this is our angle. Let's call it theta. Arcsine is the angle whose sine is x over 1. So there's our one leg is x, one leg is 1. Therefore, by the Pythagorean theorem, the other leg is 1 minus x squared. Well, what is the cosine of this angle? It's just square root of 1 minus x squared. So the derivative of arcsine of x with respect to x equals 1 over square root of 1 minus x squared. Let's try another one. Well, f of x is cosine x, therefore f prime of x equals negative sine x. F inverse of x equals arc cosine of x. So we have negative sine of arc cosine of x. And by the same process, we can evaluate that to a simpler expression. So that is, draw the triangle. Here's theta. Well, what angle? This angle has a cosine of x, so that's x over 1, adjacent over hypotenuse. And this side is 1 minus x squared, square root of 1 minus x squared. So derivative of arc cosine of x with respect to x equals negative 1 over square root of 1 minus x squared. And let's do one more. If f of x is tan x, then we have the derivative is, or f prime of x equals secant squared x. F inverse is arc tan of x. And f prime of f inverse is secant squared of arc tan of x. Let's use the triangle method to find out a simpler expression for that. So let's draw the angle, triangle with the angle whose tangent is x. Well, here's theta, x over 1. That means the hypotenuse is the square root of x squared plus 1. So we have, but that is squared. So we have the secant is square root of x squared plus 1 over square root of x squared plus 1 over 1, but all of that is squared, and that just equals x squared plus 1. So the derivative of arctan of x with respect to x equals 1 over x squared plus 1. And this is just 4 examples, but we used a general definition to find, we can use that to find any inverse.